Hi, welcome back to Moose and Chemistry. This is Net Ionic Equation Lesson 3. The last one was such a hit, I had a lot of students ask me, hey, why don't you put up another one? So I said, okay, why not? Everybody's having fun, I'm going to have fun with it too. So don't forget your -2 charge here, +1. We're just doing the oxidation numbers here just to make sure we got everything covered. So that when we go to balance this equation, everything looks okay. All right, so it looks good. Okay, oh, we got 2 NAs right here. So that means we're going to have to put a 2 in front of this NA over here. And that takes care of that. I believe that looks pretty good. And we do need one more thing because the Cl now has 2. We have to put a 2 in front of HCl. So that looks like a pretty decent balanced equation. All right, so let's write the ionic equation. Okay, we have something different with this one. We were using a gas in this time, so we didn't use a gas before. We've looked at solids, liquids, aqueous. Now we're going to look at gas. Let's see what happens with the gas. So we go 2Na plus 1, and that's going to be, of course, an AQ, plus CO3 minus 2. Again, that's an AQ, plus 2H plus 1 AQ plus 2Cl minus 1 AQ yields 2Na plus 1 AQ plus 2Cl minus 1 AQ plus CO2. Hey, wait a minute. We didn't break that one apart. That's right. You don't break apart gases. You don't break apart solids or liquids, just aqueous solutions. Okay, and here's H2O, and also it's going to remain in the same format because it's a liquid. All right, so things are looking pretty good here. So now we need to figure out our net ionic equation. All right, so we're going to NIE on this one. And so we look at this, and we're going to go, okay, what's our net ionic equation? All right, well, let's see what changed. Did our sodiums change? No. They didn't change, so they're spectators. Did our carbons change? Yes, they did, so we're going to leave that alone. Did our hydrogens change? Yes, they did, so we're going to leave that alone. What about our chlorines? Did our chlorines change? Yes, no, they didn't change. They're spectators too. So our chlorines are also spectators. So our net ionic equation is going to be CO3 minus 2 AQ plus 2H plus 1 AQ yields CO2 gas, right? So that looks good. Plus H2O, that's a liquid. And again, you can see that those are the ions that did change. So they're not spectators. So that's our net ionic equation for that particular problem. Let's do one more. So I'm going to have to clear all these drawings. Okay, let's look at this next equation. We have iron chloride plus magnesium yields magnesium chloride plus iron. So let's see if our equation's balanced. Oh, nope, it's not quite balanced. We got a 3 in this chlorine and a 2 in this chlorine. So we're going to need to get something that's going to make it balanced. So to do that, we're going to have to put a 3 here, and we'll put a 3 here, a 2 here, and a 2 there. And that should balance out our equation nicely. Notice that magnesium and iron have zeros up there. When elements are by themselves, their oxidation numbers are 0 unless they're specified. Okay, so get rid of the zeros there. So now let's write the ionic equation. Okay, now remember, we can't break apart solids, liquids, or gases. So we're going to go 2Fe plus 3 AQ plus, and now you ready for this? That 2 times 3 is going to make it 6Cl minus 1 AQ plus 3Mg over there. Solid, can't break the solid apart, besides it's an element. Then we're going to get 3Mg plus 2 AQ plus, oh, look at this. There's a 3 here. There's a 2 here. So we need to make that, of course, 3 times 2 is 6 Cl minus AQ plus 2 Fe and the solid. Okay. So now, did iron change all from the left to the right? It sure did. Did chlorine change? No, chlorine didn't change at all. So we're going to actually get rid of the chlorine elements because they are spectator ions. So our net ionic equation in this case is going to be 2 Fe plus 3 MgO solid yields 3 Mg plus 2 AQ plus 2 FeO solid. And that's this for this lesson. So you guys have an awesome day, and we look forward to seeing you on Moose and Chemistry. And you students, you keep sending those requests in because we love making these videos. Take care.